Hello and welcome. My name is Viktor, and I will take you to the last session of this web development stream on JCON. I work at a company called Vaadin. Vaadin is a web framework for Java developers. There, my role is product owner. I focus on extending the features of that framework to full stack teams where there is a clear preference for developing using client-side technology stack using the npm ecosystem and connecting these front-end UIs, web UIs to Java backends. The company named Vaadin, and to start off, I'd like to get a taste of who is in the audience. If you can please raise your hand if you are familiar, if you've heard the name Vaadin, or keep your hand down if you have no idea. I can see a couple of people raising their hands. That's great. Just we'll give a little more for somebody else maybe wants to. No, only two people. Okay, cool. So for the rest, there could be a chance to learn something. Let's see how many we have. Yeah, that's fine. Okay. Very shortly, Vaadin is a platform for building modern web application on the Java backend. And we'll see in practice a few examples of how it can be used or how you can add it to your project. Specifically in this talk, we'll later on when it comes to seeing the code and looking at the demo. But okay, the whole topic is about creating reactive UIs, using reactive templates, typed endpoints, and doing that with Vaadin. But first, before we go into details, I'd like to zoom out a little bit and think about why is it important to focus on reactive and contrast it to whatever is the alternative. The main reason, in my mind, is that reactive approach to building web UIs is probably the best one we know at the moment. And why do I believe this is actually the case? Luckily, we have some data to prove that. Stack Overflow runs a yearly developer survey, and the data from actually this year shows that among the professional web developers, the most popular frameworks or libraries for building for the web is, well, jQuery, surprisingly, and that is about as far as it can get from building reactive templates. So even if I believe that reactive is the best approach we know so far, it's clearly at the moment not the most popular one, surprisingly, right? But if we look at the most, if this is actually the approach that people want to use, are they happy with jQuery, those who use it? And apparently about 2/3 of those developers actually dread using jQuery, even though they have to do it on basically a daily basis. And if I look at the technologies that people actually want to use, there I can clearly see the dominance of reactive approach to building UIs. React.js, Vue.js, Angular, all together combined, this is the top of the technologies that people prefer or want to use if they don't use it today. So even if maybe reactive approach to building UIs for the web is not dominant at the moment, there is jQuery still very popular. I believe that the data that we see shows in a couple of years' time, the situation will change. I believe that in a few years from now, what we will see in that data is that reactive approaches to building web UIs are dominating. And this is the reason why I think it's important to focus on that and make sure that the tools we provide to web developers with Vaadin are on board with this trend, and we're actually helping build and use the tools that work best. Now, what is this reactive approach to building UIs? I'm pretty sure many of you have heard it, and I'm not going to go into any details, but to really, if I take it to the essence, it is about defining UI as function of given state. When you have some function that can be passed a state object, maybe set of properties, and it is able to produce the UI. And then whenever the state changes, this function would be called again, and again, UI would be produced from scratch or rendered from scratch. In that way, whatever the state is, it doesn't matter why or how it changes, the UI stays fully consistent with the state. There is no cases where one part of the UI was updated after a state change and the other part was forgotten to be updated. Typically, the render function also uses some sort of template, typically looking like HTML in more or less. And then there are different utility functions, frameworks, libraries that implement the rendering. If I look at an example using some of those libraries, maybe it would look something like that. The reactive approach would give developers a way to define a template, which allows to show basically all states of the application in one place and just tell whenever which state is rendered. Whereas the reactive approach, the imperative approach would be when you start constructing the UI, and then you attach event listeners, and when an event happens, you reconstruct or change a part of the UI, and you hope that you actually change every single place that needs to be changed in reaction to that particular event. Which actually it can work, but in more complex cases, it can get a bit difficult to keep track of all the changes in all the places. Now, the tools Vaadin gives to you as developers to add reactive UIs to Java backends is exactly about how to be able to follow the reactive approach and still connect to your backend and use the data and have a project. Now, before going into code demo, I would like to also mention a couple of architectural choices that you would inevitably have to make explicitly or implicitly if you start working with, start adding reactive UI to your project. And while maybe the most obvious choice is what library, framework, or tool you use for reactive DOM rendering. And this is where you could start the debate about which is the best front-end framework out there. Is it React, Vue, Angular, anything else? Or do you want to create your own and so on? But this is by far not the only choice, even though it's probably the most obvious one. From the choice of a framework for DOM rendering inevitably follows a decision that you might have to make implicitly or explicitly on the tools or infrastructure for managing the state, since now you do have the state quite explicitly defined in your render functions. They all take state, and so how do you manage it? And then there are different approaches there. You need to make a decision which one you take. And even that is not all. You also have to think of the team project structure, which then also leads to a decision on team composition, how surprisingly it might sound. And finally, then you'll get to think of the API access. In one way or the other, if you have your front-end code running the browser, you'll need to access the backend, and there are different ways you could do it, and that's also an architectural decision that you have to consider. It could be simple REST API, but it could be something else. And Vaadin would actually make these choices for you and give you a working, consistent way of building application. But it's important to realize what are the choices and what are the options, and think what are the trade-offs that they encompass. So the first option is about template rendering. This is a place where it's very easy to go and start just arguing which framework is the best, because most popular candidates have large development communities, and people just love framework they use. But I think it's important to see through that FAD and understand what are the dimensions one could use to compare those frameworks. And in my mind, the most important ones are whether or not a framework would use its own specific to its framework APIs for UI components, or would it rely on browser standard, which make UI components interoperable with other possibly with other frameworks. And the other one is the approach to rendering the DOM Does it use the virtual DOM approach and create some in-memory representation that is later reconciled? Or would it just go directly and update the DOM, because that has performance implications depending on the type of application it's choice one needs to make? The obvious candidates that come to mind, I appended one more. Maybe it's not so well known, but I want to bring it up here. On that scale of relying to its own APIs versus relying on browser standards, all three, React, Vue, and Angular, would define their own APIs, maybe because they started before browser APIs were available, or I don't know all the reasons, but the fact is they all have components and they are not interoperable. If you have a React component, you cannot use it in Vue or Angular. Whereas if you create a component using the web component standard that browsers support, you could use that web component in any framework. And lead HTML is a little rendered library that allows you to do exactly that, define web components using based on the browser standard, lead HTML and lead element. So with Vaadin, we do this choice, so that whenever you start an application with Vaadin, we would recommend you create components that rely on browser standards and use a rendering library that resembles React a lot, but instead of creating a custom format of components, would create browser standard components. In the space of state management or reactive state management, the dimension I think is important to keep in mind when comparing approaches or alternatives here is, what is the way you want to work with the state? Do you want to keep everything as a mutable object and then be very explicit about how you mutate or how you change the state? Do you want to write all that code yourself, or do you want to use some libraries there? Versus the other alternative would be using mutable, observable objects for state, so that if you want to change something, you just change it in the state in place, and then rely on the observability properties of that state to make sure that whichever other thing depends on that particular property would get informed and updated correctly. And on that dimension, I think we have the candidates here. That popular ones I could mention would be libraries like Redux or MobX, or in Angular there is NGRX. Those are all popular, but they make different choices in that dimension. Of Redux is clearly all about having the state immutable and then writing all the mutations of that state explicitly, which fits quite well to the functional programming style, but arguably it's also one of the most verbose ways to define your state management, because you literally have to then define the same thing very, very explicitly, and probably mention in a few places all the actions and reducers, which works maybe for really large applications because that allows for clear separation, but it also seems like a large overhead. MobX is on the contrary, relying on mutable state and observability of changes, so that more or less a state is just looks very much like a regular object, and then you can use its properties or change its properties very easily from any place you need to do it. But then if you follow the conventions of MobX and use the state in the correct way, you would actually still end up in having all the UI components consistently reacting to any state updates. It is arguably more suited for object-oriented programming style, where each component is an instance of a class, and then it has its own instance properties that could be mapped to this mutable MobX state object. And then NGRX is in that way similar. It relies heavily on observable streams. And if your application explicitly uses the observable concept, then maybe it's a good fit. But if you don't have it yet introduced, then introducing NGRX would probably add also additional layer of complexity related to the explicit work with observable objects. Here with Vaadin, you would actually, by choosing Vaadin, you would implicitly make the choice towards using MobX here in the application, because we believe it fits much better to creating components with lead element, lead HTML, and together that is probably our most convenient combination. On the theme of project composition, that's another topic, and that's an interesting one because it's not immediately obvious that it is related to that's even in scope of that discussion. So how can a team composition or project structure be related to this decision of adding reactive web UIs to a Java backend? Well, we have two options that I want to talk about. And the dimension here is whether you want to work or whether you want to organize the team working on it as a single full stack team, or do you want to organize it so that there are separate teams? One works on the backend, one works on the front end, maybe different front ends, different teams, and how they communicate with each other. And then that has implications to how you organize your project in terms of one project. Is it two projects, separate repositories, one repository, and so on? The trade-offs here that I see is if you go with separate front-end and back-end teams and separate projects, that is a very popular approach to. It's very common. We all know that, well, there is the REST is the default way to communicate, and then you inevitably introduce something like that with, when you have different teams, they inevitably will have to end up deciding on a common language, common point to both of them or to all of them. But that also introduces an additional communication boundary, because it's not as easy to ask somebody in the other team compared to how easy it is to ask somebody in your team. You probably have different sprint rituals like dailies and so on. And it's okay if there are reasons to go for it, but it's important to realize that it is actually an additional communication boundary, an additional overhead to pay for. It makes sense when there are different front ends for the same backend, for instance, iOS and Android and web for the same backend, then they would probably be worked on by different teams. But if you know upfront and there is a single front end and a single backend, you might as well think of, do you need to introduce this boundary and this complexity by separating the team, or do you want to keep this one team working full stack? And then if you do choose that option, you will end up most likely, or at least you will have incentives to also think of a single project repo, because if it's one team, one project, would be more convenient if the entire source base is in one repo and worked on at the same time, and then it probably deployed also as a single deployable artifact. And by doing so, you would cut the communication costs somewhat, and also the management costs, because it's well, less things to manage. But that also at the same time contributes to creating some sort of a monolith. So if your application is not going to be huge at any point, then you might as well consider that. And in the microservice world, you could actually still go with that approach if you consider your full stack as being API gateway on the back end and the web UI on the front end. Then it would be worked on by the same team. And then whatever data you would need from your microservices on your front end, you would have one single team that decides how to show that data on the UI, and then how to get this data from your microservices backend in your data center or your cloud. So this is how I think this project structure, team composition becomes also a factor of consideration. And then finally, the fourth point here would be about the API access and the dimension. I think it makes sense to use to compare the options here are the level of abstraction we're talking about. Is that an application level protocol, or is that a network level protocol? And by saying network level protocol, I mean things like REST, which is, if you want to use it, you would literally make HTTP requests using a library or using an API like the browser Fetch API or library like Axios. You might as well have some wrappers on top of it, but then you'll add these wrappers yourself. Another alternative sometimes for applications which rely much more on real-time data, you might think of maybe WebSockets. And in that case, you might have things like gRPC to consider. There is an alternative to REST, is a GraphQL, that is still, I would argue, it's in between, in my mind, between low-level network level protocols and higher application level protocols, because GraphQL allows you to express your data requests using a query language similar to SQL, not really directly create HTTP requests there. And with Vaadin, we offer you an alternative to REST, or a wrapper on top of REST, which allows to a wrapper on top of REST, which allows communication, so that when you access your backend, you have all the type information, you have code completion in your UI code, and you have security built in to talk to organize the communication between client side and the server. So obviously, when you use Vaadin, you would end up having things like you would use the functionality that we provide. Now, to recap, so with Vaadin, we offer a way for developers to add reactive web UIs to Java projects. And the set of choices that we would recommend you make is to use a rendering library that is based on web browser standards and uses direct DOM manipulation through that. Would use implicit or a state management library based on observable effects and implicit changes, which is MobX. We would recommend you to have a single team, which is full stack and work on the same project in the same repo. And we would recommend you to use application level API access, which has authentication and type safety built in for you. This set of choices is by far is not really the only sane set of choices. You could make different choices, but the trade-offs, if you do so, would also be different. And now I would go to show things in the source code. And also, I see there are 2 hands that are still up, so you can lower the hands down. And as to questions, I would ask you to keep the questions to the end of session, but if you can also type them in chat, but I'll take them in the end, if that's okay. Now I'm about to change the sharing so that instead of sharing this, I'll share another screen. Okay, can you still see my screen? I assume, yeah, still sharing. Now, to see in practice how that's going to work with Vaadin applications or how one can add reactive web UI to a Java backend, I would start by going to, I think the easiest way to try it out or start a new project would be to use the start Vaadin.com like an application builder and create a very simple application using that tool. You will then download the project and then you can run something really, really quickly with the basics set up for you. In order to use reactive approach to UI would be here on the application settings tab, you would select that you want to build UI using TypeScript and HTML. That requires a more recent version of Vaadin. And this would set the default for the entire project. And then you could change this default per view. Basically, you can actually have the project where some views would be built using Java APIs, which are not really reactive, but this is the traditional Vaadin approach, and you can have this both in one application if you want to combine. But for the sake of this demo, I would keep the defaults, which means that all the views here are created using TypeScript and HTML. I would add a master detail view, something like this, and also a dashboard view, and then download the application. Now, once everything is set up, I would download the project, and then you can import it to IntelliJ or Eclipse and run using, well, it says here, maybe Spring Boot run. At the moment, I will open, instead of opening this particular archive, I would open a project that I already modified based on this. So not exactly starting from that same point, but a very similar application. So here is, oh, let's see. Here is what I have. Let's see. Should be really, really similar, unless a demo effect kills me. think a demo effect kills me. Okay, but before it, or while it does its things, I want to first look at the structure of the project, because that's one thing to consider here. So what you get is a typical Maven project. At first sight, you have the POM file. You can see that in this particular case, it's based on Spring. And then it has the dependencies like many Spring applications would have. But in addition to that, it uses the Vaadin Spring Boot starter. And in addition to what you would see in a typical Maven-based project, you have also a frontend folder in the same project structure. And this is the home for the web UI. It's built using TypeScript, and then every view would have, or you can create different components, and different views would live here. And then communication between this project using TypeScript is built at the dev time, or when you build the project, would be compiled to an optimized bundle if you build for production, or compiled to development-friendly bundle if you run in development mode. And then it has hot reload and things like that. So it's effectively what Vaadin allows you to do is you could combine front end and back end in one project and have things like hot reload for you. Let's see. Is that now up and running? Yes. So, user. Okay. The application here is similar in the sense that it has a master detail view, like the one in the start Vaadin.com, and a dashboard view that shows kind of a chart, how many contexts grouped by company. So the points I would like to highlight, so what makes this reactive UI? First of all, if I look at this particular view, this would be list view. You can see that the UI is expressed as essentially there is a render function that takes a template and refers to the state. So whenever the state changes, the entire UI will get re-rendered. If we look at details, it has the grid with a list of items taken from the state. So whatever contexts are there, they are displayed in the grid. And then down below, there is the contact form. This is the editor that you see aside from the grid. And whenever contact is saved, this change is sent to the state. And if I see what is actually save contact, this is an operation that modifies the state. At that point, the grid already will get re-rendered. And then it calls the backend. So what is this? Save contact. And then eventually, after the backend is notified, it will also try to reload from the backend. But first, what it does, it just changes the contacts list that the client side, the browser, thinks there is, and that already triggers update to the grid. Let's have a look at how that works. Here, say I want to change this to Sam, and whenever I click save, it's get reflected here automatically. And if I see what I needed to do in order for that to happen, at no point did I have to call something like grid.refresh or anything. The only thing I actually end up doing was I updated the state by updating an existing contact or creating a new one if I do it so. So that's what makes it reactive. And another aspect I want to show and highlight in this demo is the typed endpoints, the part that works together with reactive UIs. That's the part that handles the communication layer. Here you can see something called save contact. So what is it? If I try to go navigate to the file, I would see something. This file is generated from service endpoint.java. And if I try to find out service endpoint, it has actually a delete contact method. And what happens here is I have an endpoint class in Java. with whatever logic I want to run when an event happens. In this case, it would go to a repository and delete the entity there. It might as well contact a microservice. It might refer to its local cache. It might do whatever you want to do on the Java backend. And then the way how your client-side code interacts with that, the client-side code resides in the same project, and all the type information about what is a contact, what properties it has, what are the endpoint methods, what types it accepts and returns, all that type information is available in TypeScript. So in this case, I could see that once I start typing contact, I have code completion. I know what is the type of data that is expected. I know that it's contact. I know what contact is. I know what properties a contact has, all of that. And I didn't have to define this type information anywhere except for my Java code. So since I do have contact type in Java, the TypeScript types for the same entity are automatically generated, and this project would use them without additional work from my side as a developer. For instance, here, if I go to contact.java entity, this is the Java entity that essentially defines the contact TypeScript type. Okay, so this was a very short demo. I would like to jump over to our slides, which would be here. And just to recap, so what is the reactive part? Is the way that whenever you define your template, your view, the UI layout or UI content, UI logic, you refer to parts of state. And then whenever you want to change the state, you modify the state. And then you don't need to think about which components need to re-render. That's the reactive part. And then the typed endpoints part here is about being able to use endpoints, effectively call your backend Java methods from your client-side code using type-safe API, with the security handled for you. That's the parts about typed endpoints. Now the security part here is that by default, any APIs, any part of any methods exposed on the endpoint classes would not be accessible unless you're logged in to the application, and you can override that default by adding an additional annotation to the entire endpoint method, or endpoint class, or individual methods. You could also then change the requirements per specific endpoint. Say you could require roles that need to be present on the user principal in order for that method to be executed. So the security is defined on per endpoint granularity. And then if you try to call something without having the right permissions, that call will just simply fail. From Omar Stud, at some point, I wasn't safe contact a recursion. Okay, sorry, that wasn't, never mind. No, it wasn't a recursion, but yes, there was the same method name used from different namespaces. Another question from Andre. So if we built the UI only with Java, as seen in the starter page dropdown, we have no reactive frontend. If you build your entire UI with the Java APIs, you most likely will end up having the UI built in the approach or shown here. So I wouldn't call this approach reactive. It doesn't mean that you cannot find a reactive approach if you rely on these APIs, but it's certainly not the intended way to use APIs. So I would say, yes, it wouldn't be reactive by default, at least. David, could you please recap how the backend endpoints are generated? Right. How this happens is, I didn't have any slides, so but for that I could maybe share something on my screen. Let's see. Does it work? In short, they are generated by the if you build it for production, they are generated by the Maven plugin. And if you run the application in development mode, then there is constantly running watch process that looks for class changes in your project and scans for endpoint annotation. I'll say service endpoints.java. It has this endpoint, and I'm still sharing. I assume I am. It has this annotation, and so it would detect a change to it and regenerate the files in the generated folder inside frontend. Let's say I could say there's now a method called delete2, and okay, there's delete2, and I save my project. It rebuilds eventually, and at that point the change is detected. And if I go to client-side code, let's say, where was it? List state here. I could see that in the generated endpoint, there is now another delete contact method, which I can use. Did that answer the question on how backend points are generated? Okay, if there is something else to ask, please follow up with a different question. Support for accessibility like screen reader in the Vaadin components. Right, that sounds like a pain point from somebody, from Sasha. And not that it has direct connection to the content of this presentation, but generally we at Vaadin want to support accessibility standards. I know that at the moment there are open issues, a number of them, which are being assessed and hopefully addressed soon. By default, I would say that the component set that Vaadin provides has good support for screen readers, but I know that at the moment, if you try to use all the components, not all of them would pass the latest requirements from, let's say, the EU requirements or German requirements. And I know that there is effort inside Vaadin to update components and improve some of the missing accessibility points. Right. From Omar Stud. What are your thoughts on the old Java-only server-side model Vaadin approach versus the new approach with TypeScript? Is Vaadin planning to move away from the imperative approach long time? Here I would say that the approach I presented now is an extension with an intention to invite more developers to use Vaadin. I don't think it is reasonable to, or even if it makes sense to expect that people who are using Vaadin exactly because it is a great framework for building UIs in Java, I don't expect these people to suddenly change their mind and migrate to some other tool just because some Stack Overflow developers survey tells that jQuery is not popular. So the answer to that would be no, I don't think we will, we as a company, Vaadin, will move away from the Java approach. What I presented here is more of an attempt to invite more developers or more different types of teams to build applications with Vaadin. How can I combine it with other JS frameworks? Here, the answer is it is possible, but with Vaadin, we want to provide a recommended set of frameworks that work together. Let's say there was lead element, MobX, something else. It's all working together and we tested that it works. It doesn't mean that adding another JS framework wouldn't work necessarily, but it means that you'll probably need to figure some things yourself. In general, the frontend folder is the place where you would add any dependency to anything npm. You could use Vue if you want, but we probably don't provide, at least not from to start from, we probably don't provide the tutorials based on that. But if, for instance, you want to use a library from npm, third-party libraries, let's say D3GS for visualizations, or other components from Salesforce, from whatnot, then it's absolutely no problem. It would be as easy as writing npm install your component, and then you can import it from your code here. Which Vaadin version did I use? Here, well, I like to live on the bleeding edge, so this uses 18 alpha 1. But the key point here, the same would work mostly with 17 also. 14, no. Okay, as much as I wanted to say yes, it's a no for 14, because In order to use client-side tools like lead HTML, like TypeScript, we did quite a big change to the way how the application starts up, bootstraps itself, and that is not compatible with 14. It was introduced as a breaking change in Vaadin 15. And so this demo builds on it. Thank you very much for your questions, and have a great evening.